Okay, they should be starting to come on. I'll wait for the first person. You're going to get cranky because I'm 2 minutes late. 10E. 10E.
10E. Oh, that's my group.
I know. Here, you can say hi while I go get my stuff.
Hi, guys. Mr. Weiss will be back. He's borrowing my setup for today. So, oh, hello. So there's a little bit of a learning curve with my setup. So what am I doing here? This is my room. Mr. Weiss is taking over my room. I'm on lunch break, so I'm going to go get my dinner and come back, and I'll sit and, you know, I'll troll Mr. Weiss a little bit when when he gets back. No, I'm kidding. This is not a do-rag. I need a haircut. So wow, you guys are quite chatty. Oh my goodness, we're live. It actually says live. Oh. Do you need space in front of it? Blow stuff up.
Let's hope not. Just a quick demo.
So I'm going to remove all the flammable items on my desktop. So that's if you blow something up, I'm going to run away. So first I need my USB stick. Must save the data. The data. Where's the G? Oh, there's no GTA, guys. I don't steal cars.
Oh my God. Okay, so. Thank you, Mr. Lee. I appreciate it. I owe you a multiple in a big way. Hello. I'm taking this back from that. Hi. Where do I have to look? I got to look this way, huh? Okay, that's really strange since the monitor's over there. So, my people, I hope you can hear me. Can you hear me with Mr. Lee's whatnot on? I don't really have to hear you, but this way I don't get feedback, apparently, if I do this. Okay, so, my people, I'm here in school. Thank you, Lily, Tadashi, and others. So, I'll just kneel. This is really strange. I'm here because I want to do this experiment with you right here at the beginning of the hour. At about 12-ish, Mr. Blessman wants to speak to you. So about AP physics, frankly. So he's going to do that. But for now, we need to do a quick experiment while I'm here in the building with you. Then when we're done with that, we'll return to the effects of alcohol on our bodies. I'm going to send you a couple sheets to read about that as well, okay? All right, so here we go. What I've got, I just did, one is more or less a blank. I don't need that. But the other is full of ethanol. Where did I get the ethanol? From here. This is spiritus. You might have it around the house, Bren spiritus. It burns really well. Should you draw this experiment? Yes. And all you got to draw, Shilpa, is a test tube full of ethanol. So it's pretty easy to draw. What we're going to do is we're going to heat up. We're going to heat that up. There. We're going to heat that up. What is that? What stuff is that? Can you guess? What am I holding up? A piece of what? I'm going to make it so it's nice and straight. Yeah, thanks, Lee. And Deacon, good. It's copper. So what I'm going to do is I'm going to do this in 2 steps. And I got more copper in case I screw up, okay? And I got to do this the second part fairly quickly. Okay, so let me light up the burner without destroying Mr. Lee's headphones here. And off we go. Great. Can you still hear me without those? Yeah, exactly. It's copper. Okay, so here we go. That was quick. Okay, so now you can't see that at all. All right. Okay. Okay, so folks, these don't stay in my ears very well. I guess my ears are too big or too small or something. So I've got a Bunsen burner. I've got it going really hot. So it's that inner blue cone, which I guess you cannot see very well in the video. So be it. And what I'm going to do now is, oh God, I'm going to hold the copper. I feel like the Hunchback of Notre Dame here. I'm going to hold the copper in here for a second and show you what it does. You might be able to guess what it does anyway. I don't need to wear them. You can still hear me and it's okay? All right, then I'll try it without them. You can let me know if it gets bad or something, okay? Okay, here we go. All right, that's what I want. Okay, so what happened to it? It got what color? It got what color? Same on the other side. What happened where I burned it? Or where I put it in the flame. Yeah, it got gray. Good. So let's figure out what the gray stuff is. You guys got to guess what the gray stuff is? I'm going to put your guess on the board. You ready? What's the gray stuff? In other words, I had copper plus something, and I formed something over here, which is gray. Okay, so the kind of gray stuff I formed, I can hold it now because it's cooled down. The gray stuff I formed, what do you suppose it is? It's not this lower stuff, it's the top stuff. So it's really the gray stuff that I'm talking about here. Hint, what do you suppose it combined with in the air? What do you suppose it combined with in the air to make the gray stuff? So the gray stuff is probably what? All right, thank you, Tom. So it's copper oxide. Let's write that as a word first, but you're going to figure out the formula. Yeah, thank you, Tom. You're on the stick. Good. Okay, so here we go. I'm not. Where'd I put the flipping marker? I put it back in there for some reason. Okay. Thank you, Mr. Lee, but I don't need that right there at that time, and I don't want to spill it all over the place. Good. Okay, so obviously reacted with what from the air, right? What did Tom say? So what are we reacting with in the air? So I got Cu plus what makes copper oxide? Fill in the blank here, folks. Now you can see. Oxygen, good. Oxygen gas from the air. Remember, air has a lot of stuff, but most of it does nothing. It's not reactive. But the oxygen is, All right, that's why we get a lot of rust. Okay, so what do I put here for my chemical? And what do I put here for my chemical? Let's see if you can guess. So what's the formula? Oxygen gas means I got what? What do I write here? That's the name, but I want the symbol. Give me the symbol, oxygen gas. And give me the symbol over here, copper oxide. See if you can guess. No, Tadashi, there's no O in the air. Not a single O. Hint, hint, hint. There's not a single O. What is there in the air? Help out. Come on, oxygen gas. You know this. Brinkelhoff. Brinkelhoff. Thank you, Sarah. It's O2. If it's an element in the air, then they always come in pairs. It's diatomic. And then thank you, Lee. CuO is right for copper oxide. So let's go ahead and balance the sucker. How about I just put a 1/2 here? Remember, you can do that if it's I can put a 1/2 in front of any Brinkelhoff, anything that comes in 2s. Okay? All right, that's it. But that's not the demo. That's only half the demo. Let's do the rest of it. Okay, you ready? Here we go. Where's the damn lid? Sorry, this took a while. I got kicked out of my room at the very last second. So I'm kind of dying here. Okay. I'm going to try and be a better scientist and put my goggles on. I got so flustered I forgot them. Not so smart. Okay, so I'm going to do the same thing again, but once it gets hot, I'm going to put it into here, okay? All right, you ready? And I got to do it quick, so be watching. Got to get it pretty hot. And it didn't work. Shoot. Because it doesn't fit in there very well. I'm trying. Let's try it again. Dang it. Okay, so here we go. Get nice and hot. Yeah, I'll do it this way so you can see it better. Dang it. I tell you, this is not my day. Okay, the piece of copper is too wide. I can't get it to in the freaking tester. So I'm going to make a more narrow one. If I can break it with my fingernails. Do the other side. Come on, puppy. Yeah, all right, there we go. All right, there it is again. Okay, so there's my copper. We're going to do step 1 again and oxidize it. Make sure it's nice and black. Okay, so there we go. Nice and black, right? Both sides, that gray copper oxide that Tom predicted. That's what that is. Okay, now here we go again. This time it should fit. Heat it up. I'll get so you can see it. Heat it up, heat it up, heat it up. Whoa! Look at that. Look at that. That sucker came out clean as a whistle. Remember how gray black it was? Whoa! How did that happen? Well, let's find out. That's crazy. It somehow must have reacted with this stuff, right? Look at that. It's beautiful again. Totally clean. So what happened? Quick reaction, okay? CuO plus, and that's solid, right? That's the gray stuff. Plus, who was listening? What did I say was in here? Did I tell you already? What's in the beaker? What's in the beaker? In fact, let's get that out of the way now that we've done it. What's in the beaker, people? Ethanol, thank you, good. So here we go. And see if you remember the formula, right? C2H5 and then OH, because it's ethanol, right? And that's a liquid. Well, that's cooled down now. What did I get again? What formed? Oh man, your video cut out. I hope you're still there. Are you guys back? I sure hope so. Yeah, it looks like you're back. Okay, you're back. Thank you. Good. So what formed? Clearly, what formed again on the other side? What does it look like? It went from CuO, it went from the gray stuff to what? It went from the gray stuff to what? Pure copper. Thank you, Tom. So it went back to copper. And you might say, but Mr. Weiss, that's really stupid. No, it's not, because it turns out something happened to do that. Something happened to the ethanol. That's the interesting part. So what? Okay, let's find out. Ethanol looks like this, right? So what must have happened is somehow I got another H. I got another thing. I gotta put this on here. So what happens is I get CCOH, but I gotta get rid of this other O. Gotta get rid of this other O. So the other O, can you see that? Now you can see it. So I got an O I got to get rid of, right? Well, where can we put it? Where can we put it? Essentially, what you can do is you got to put it here. So it combines with the ethanol, but that's not done because you guys know that oxygen makes how many bonds? Like it's not just another O, it's got to be doing what? And by the way, while you're thinking about that, I got to get my stuff sitting over here. Okay, I'll be right back with you. Editing range, and then we'll just kick me out. There. That's computer. Okay. Sorry about that. Okay, I found what I need. So essentially, we oxidized ethanol. We added more oxygen to it. And let's see if you wrote anything. No, you did not. Okay, so the problem with O is it takes two bonds, not one. So it must be another H that I knocked off, must reattach here. And I've got a double hydroxide. So I've got, it's not ethanol anymore. It's like ethandiol. I'll write that as a question mark. Ethandiol. Well, it turns out this one, 1, ethanol does not exist. So what happens? What happens? My people, what happens is called Erlenmeyer's rule. So what we've done is, I need you to know about this experiment. Let's put a title on it. We've oxidized a primary alcohol, and that is ethanol. Primary, you ready? Primary is pretty easy. It means the OH, the hydroxide, is on the first seat, or last, right? You can guess where we're going. Another day, we're going to talk about what happens if you have a secondary alcohol, but this is a primary. Okay, so what happens is I get two OHs on the same carbon. That can't exist. Thank you for joining us, Noel. You can watch the rest on video later. So what we're going to do is we're going to see what happens. Can you see up here? God, I don't know how he does this. I guess I gotta sit. I don't like sitting, as you know, but I guess I got to so you can see me. Okay, so the question is, why doesn't this exist? Okay, turns out it's unstable. Let's draw it again. So we have OH. There's our special guest star. We'll be with him in just a moment. We have an OH, and this is unstable. And what happens is, you can just about guess, these OHs, I can't have two on the same C. They kind of crash together and make a water. So what I get out of here is H2O from essentially this guy and this guy, or it could be the other way around, plus, here's what's left, C, C, and now this becomes a double bond to the O, and we're gonna name this, and then I'm gonna have my special guest star today take over. This is called an aldehyde. It's got a double bond O at the end. That's how I know it's an aldehyde. We're going to work more on this another day, but that's why this is unstable. We've now oxidized a primary alcohol. Okay? We'll do another one another day, and we'll do the secondary one another day. And I'm going to leave this now in the healthy hands of your physicist, pal, and mine, Mr. Blessman. Mr. Blessman, take it away.
Thanks, Chris.
Well,
Hey, guys. Good to not see you. Well, good for you to see me. Wait, how low do I have to duck to get on here?
pretty low.
You short, Mr. Weiss, or something? What's going on here? I have to like kneel on the ground or
Mr.
something.
Lee likes Smithy. I don't sit on the ground or something.
Where's the camera anyway? Is it on this thing?
It's on this.
Is that that? Okay.
section.
Oh, I can lean it up.
Yeah, you can.
Whoa, here we go. That's more comfortable. Okay. Cool. Okay, I appreciate your time. I wanted to talk to you a little bit about AP Physics briefly, especially because there's a slight mistake on the first version of the sign-up form for 11th grade that went out in terms of the courses. So I'm just going to do a little bit of a spiel that should remind you of the conversation. Can I move to my left so you can finish looking at the board? I think that's what you said. Okay, here, there we go. Is that better? Good? Okay, good. So I'm going to talk to you for a second about AP Physics. The spiel that I posted on the transition site is correct, but the sign-up form was slightly wrong. It's been corrected, but in case you printed it out and we're planning on filling it out, there's still a mistake in there. I also want to give you the opportunity to ask any questions about the course. Now, in this context, you'd be asking it through the chat, but I think that would be okay. Okay, so here we go. As you are maybe familiar, I am the AP Physics teacher at JFK. I've been doing this for quite a while. AP Physics is a bit of an odd beast in that there are 4 different courses that actually are on the slate and that exist. There's only one AP Chemistry, there's one AP Biology, but there are 4 different AP Physics courses. So I did want to explain that a little bit because it is and can be quite confusing. The 4 courses are AP Physics 1 and AP Physics 2, which are roughly said algebra-based, meaning mathematically less sophisticated. There's no calculus involved in AP Physics 1 and AP Physics 2. The other 2 courses are AP Physics C Mechanics and AP Physics C E&M. Those courses are calculus-based, have more mathematics involved because there is calculus involved in those courses. That's the big difference between the overall structure. Now, I've been doing this a long time. It's my 23rd year doing this. I feel so old. Okay, 23rd year teaching AP Physics, and I was actually teaching for about 5 years before that, so I'm a pretty, oh my God, I'm getting old. Anyway, so I've been doing this for a long time. I've been also serving as a scorer, a reader for the AP Physics exam for 11 years. Actually, normally we fly to Kansas City, and then all the exams come to Kansas City and Missouri, and we grade the exams there. That's not happening currently. They're online grading, and I will be doing that this year as well. But just that means I have a lot of insight, I think, in terms of how the exam works, because I know how it operates. I've also written quite a few questions for the exams. 2 other important things to point out. One important thing is regarding university placement. You guys maybe are thinking about that, maybe not. It's kind of early 10th grade, but a lot of our diploma students, if you are a diploma student, choose to study either in America, in Great Britain, in Holland, Netherlands, or in Germany. Those are the main options. And depending on which route you're taking, AP Physics, if you are going to pursue a degree that might require AP Physics, such as engineering, medical school, or a science major, that is affecting that to some degree. And specifically, the 2 big things that I found relatively important is that if you study in Germany, you want to study physics, chemistry, engineering, something in science, they generally require 2 AP Physics C courses, and passing grades on those, actually they require 5s. So AP Physics C is the course you need to take for the Germans because they're hardcore about their calculus. The other countries are a little more flexible. The US, Germany, US, Netherlands, and the UK are happy to accept AP Physics 1 or AP Physics 2. And generally, they also want you to get 2 of those scores if you're going to pursue studies that require that: engineering, physics, chemistry, medical school, those kind of things. So this is why we offer all 4. It seems almost crazy for a small school. We're a very small school like us to offer all 4, but we do. We offer all 4. But I can't teach them all at the same time. We don't have enough students, and we don't have enough of me, basically, because I can only teach 1 of these sections a year. So we rotate them on a switching on and off schedule. So it's important for you to know, and this was the mistake on the sign-up form that has been changed, but I just want to make sure you're aware. For the coming school year, when you're 11th graders, juniors, as an American would say, the course offered for next year, this coming year, is AP Physics C, Mechanics, and AP Physics C E&M, meaning the calculus-based course is the one that starts in the fall for you. In your senior or 12th grade year, AP Physics 1 and 2 will be offered. So if you only want to take one of those, then you have to know that, of course. If you're going to take both anyway, that works, then it doesn't matter, really. You sign up for both, doesn't matter which order they go in. I think it's a great sequence. Either direction, the students who are just now completing the 12th grade AP Physics program, actually we have 5 or 6 students who have experience completing both courses. So if you want to get some feedback from actual humans, which always is useful, Weiss is, for example, one of those. Hannah Cook is one of those students. There are several others. If you're interested in actually talking to a student, Sam Wiltsius is also another student who's doing that. Okay, so if you want some feedback. I'm going to look at the chat here for a second. So is Physics 1 and 2 enough for med school outside of Germany? Actually, for medical school, if you're going to study medicine, I would think Physics 1 and 2 are actually probably the better courses. Those are the traditional pre-med physics courses that you take at an American university, also called college physics, which has more breadth. So it has more topics such as modern physics, which includes some work on nuclear physics, radiation, which is important for medical school, as well as thermodynamics, heat exchange, which is important, and also fluid dynamics regarding gases and those kind of things, which are, of course, also important for lungs and study of the blood flowing through veins and all those kind of things. So actually, AP Physics 1 and 2 is a good course for if you're going to study, go to medical school in the US, especially, I think that's a great choice. Let me look over here. If you do not take AP Physics 11 but choose to take AP Physics with Kaplan 12, okay, that doesn't work, Lily. So just to cover it again, AP Physics C is being offered during your 11th grade year. So if you want to choose that course, you have to choose it in 11th grade. You cannot take it in 12th grade. Then to answer your question, generally, most students who do take AP Physics C as juniors are taking calculus at the same time, AP Calculus. So if you are in that course, that would be okay. That would be the right choice, I think, in that sense. I've had one student take AP Physics C as a junior who was in pre-calc. Rhea Mickey? No, not Rhea, her sister, sorry. Say again? Lorelei Mickey, thank you. Lorelei Mickey took it as a junior. It worked out for her. It was hard course though, but you can do it. But you know, I don't want to advise Lily specifically on whether she should take AP Calculus as her junior year, but I know if you can get in that course and you can take it, you know, hey, get with the most advanced courses that you can handle. That's at least my general advice. Sure. So there are 4 courses for AP Physics, and I'll write it on the board. That's a good idea. Here we go. So we have, for the coming year, 21, 22, we have AP Physics C, and those are 2 semesters. This first semester is mechanics, motion, momentum, energy, those kind of things. The second semester is electricity and magnetism, which is exactly that. We're talking about electrostatics, resting charges, moving charges in circuits, as well as electromagnetism, currents creating magnetic fields. And then during your senior year, 22-23, the courses we have are AP Physics 1 and AP Physics 2, and they're just called that. So this is another strange thing. But of course, they have topics as well. So AP Physics 1, for example, does have mechanics, but it also has fluids, and it also has thermo. Okay, AP Physics 2 also has E&M, as mentioned here, but it also has optics, and it has modern physics. Okay, and this one here, as mentioned, there's a lot of stuff here. This is with calc. This is no calc. Okay, so that's the overview, and it is showing up over there. Let me see the chat here. The AP, that's a good question. On the website, it's corrected, Shilpa. So the website, if you download it right now, if you go to the transitions area and you get that form from there, it's correct. But trust me, it's correct. That in the coming year, it's AP Physics C for your junior year. In your senior year, it'll be AP Physics 1, 2. Okay, so just be aware of that. And yeah, so there we go. And let me see where we are here on the chat. I just can you restate which course I did? Would you recommend AP Physics 1 and 2 or a different physics class for somewhat interested in biochem?
That must be Natalie.
Yeah, it is. I think you should probably take we have a regular physics course as well. But I would recommend that anybody who is considering a career in science should consider an AP course. I think that's good. If you can handle and believe it, you can handle it. I'm sure you can. If you want to be a biochemist, I'm sure you can handle it. Because the AP Physics 1 course, the AP Physics 2 course, those are going to give you a good foundation for biology, chemistry in terms of learning things about fluids, thermodynamics, and those are important topics for you to have a foundation in if you're going to go into science. So any scientist, I think, should take AP Physics. I think that makes sense. Specifically, if you're going to go into the physical sciences or you're going to go into engineering, you should definitely take AP Physics C. I think that's important. And my personal preference, come on, people, take both years. It's awesome. It's a great ride. Like I said, 6 students that did it this past year, and it really is quite a good community, and I think it works out very well. Let me see what time it is. We're at 10 after 12. And there's the thing on the board. And let me just look at the list I have here in terms of anything else we need to do to talk about. Standard stuff at 6 periods per year. I mentioned that. Oh, yeah, the exam lengths are slightly different. AP Physics C has, those exams are only 90 minutes long. So there are 2 90-minute exams that you take in May to get credit for that course. For AP Physics 1 and 2, the point of the class is, again, you think, oh, this is calc, so it's so much harder. This is no calc, so it's so much easier. Yine, I would say. No calc, fine, but it has much more depth in terms of explanation. So you have to be able to reason about physics at a much deeper level for AP Physics 1 and 2. So explaining why is this case, why is this light bulb brighter than this light bulb, that kind of stuff. In that sense, it's not necessarily easier. Depends on really your skill set. Some people are really good at cranking out equations and just, solving this stuff and coming up with the answer. 3.4 amps, great, but why? Oh, okay, now I need to explain it. That's actually a different skill. Okay, and that's also another reason why I really think both courses together form a great set, because you have the real mathy stuff here in AP Physics C, and the more explainy stuff and writing and thinking about physics in AP Physics 1, 2. That's why the 2 courses really go well together. Plus, of course, AP Physics 1, 2 has topics that aren't included in AP Physics C, mechanics and E&M. That's another good reason to take both. Okay, I think I've covered all the details on my list here. And I actually have the form here. And where is it? Here. There we go. And you can actually see, I just printed that out. Am I holding it right? There we go. AP Physics has the corrected boxes there. So AP Physics 1, 2 is blacked out here for your junior year, and AP Physics C is open. This is different from the version that you saw first. If you were a good organized student and printed out right away, you have an incorrect form at this point, I'm sorry to say. So I am open for more questions if you have any. If you don't have any questions, oh, there's also the Schnupperwoche, which this time you're not doing a lot of schnuppering, but there is a Woche, I guess. So just 15 minutes of hang out with questions kind of situation tomorrow on during lunch. I have that scheduled. You can also come over there, and I'll be on Google Meet, which will be a little easier to interact than over YouTube. But hey, there we go. I appreciate Mr. Weiss's time here. He gave me the time on this class. I'm really thankful for that. Okay, cool. If there are no more questions, then I will leave you at this point because there are no more questions. Correct? I gave you another second there to ask a question if you had one. No questions? No questions. No questions? Okay. Then, thanks, Chopin, and thank you for listening, people. And you guys stuck around mostly, so that's cool. And I'm going to now. This is okay. I'm going to ask Mr. Lee to. How do I get over here now? Is it this mouse?
Yeah, all the way to the left.
Oh, I just go to the left. Oh, here we go. Okay, cool. Okay, thanks, guys. Bye.